Science is I'll just tell you some general things. It's can be very boring. Can be very hard work. But it's very satisfying when you can create something which actually has some value. And I'm not talking about money.
Hi, my name's Chitrita Nair, and this is Aneesha Vora, and we're from the Full Steam Ahead Club. And here we explore all aspects of STEM and also art. And today we have the privilege of having with us Professor Cutting, who to speak with us about his groundbreaking research with probiotics. So, yeah.
So, Professor Simon Cutting is a bacterial genetist with over 25 years of experience with Bacillus since graduating from Oxford University with a D.Phil in 1986. His D.Phil was on understanding the genetic control of spore formation in Bacillus subtilis. After spending 7 years in the renowned laboratory of Professor Richard at Harvard University Biological Laboratories, USA, he spent 3 years as an assistant professor at the University of Pennsylvania Medical School in Philadelphia. He then returned to the UK in 1996, and since then he has worked on developing bacterial spores as novel oral vaccines at the Royal Holloway University of London. Professor Simon Cutting is the CEO and founder of Sporegen, a UK-based biotech company focused on developing innovative spore-based solutions for vaccines, probiotics, and drug delivery. The first thing I wanted to start with was that you wear so many hats as a scientist and as an educator, and you've started your own company. So could you please tell us a little bit about that?
The company is called Sporegen. The name Sporegen from bacterial spores. And I started it 13 years ago. And it was really because in science, it's typically you have good ideas, but translating an idea into a product is a different matter. And for that, you need commercial skills, etc. And when you speak to scientists, they always say it's interesting. Everything is interesting, which is great. But of course, you have to have an application. So I decided I had lots of ideas, and I knew some of these ideas could go to the markets, could be used by people or in animals, agriculture. So that was the motivation to create a company. And when you create a company, you then have to bring in investors, people who are interested in really making money. They want to see the company grow. And yeah, we've done this, and we have a number of products which we've licensed to companies across the world, including India, America, Vietnam, Europe.
Could you please tell us a bit about some of your products that you mentioned?
Yes, yeah, of course. So tell me if it does that again. So, for example, this is a product which is sold in America. Probably, well, I'm not trying to advertise anything, but it's called Flora, and it's an American company, and they make a probiotic, and the bacteria in this probiotic is discovered by me. And this particular product produces a lot of riboflavin, which is a vitamin. And people can benefit from this, hopefully benefit. It's good for immune health. And we as a company, we developed all of the scientific background why we prove that if you eat that bacterium, you will produce vitamin B2, riboflavin in the body. And we have a number of products like this. And another one is called HU58, which I believe is sold across the world. So we develop strains which are advantageous. So, for example, we have another bacterium which breaks down gluten. So many people have gluten intolerance. Gluten is present in wheat, So there's a market for that. We also have developed more medical products. For example, in America in particular, there is a disease called Clostridium difficile infection, which kills about 30,000 people a year in America. And this is an intestinal infection you get in a hospital. And we've been able to identify a number of bacteria which produce a compound which kills Clostridium difficile. Clostridium difficile is a pathogenic bacterium. And again, if you eat those bacteria, and you do this on a daily basis, you will be killing those bacteria which cause the disease. And another product we have, for example, 2 days from now, I go to a company in England. We have a product which is suitable for a chicken, an infection of chickens called necrotic enteritis. And probiotics are very simple, very convenient, straightforward products to produce. And there is a health benefit. So we're in the world of sort of quasi-medical products. Many medicines, you may or may not know this, are very sophisticated and they cost billions of dollars to produce. And unfortunately with that is the medicine may be fantastic, incredible, but someone has to pay for it. And in America in particular, it's paid for through insurance. So people have medical insurance. But of course, if the medicine is very, very expensive, you have to pay a co-payment. So if your medicine, let's say, costs $20,000 a year, you will have to pay $2,000, 10% as a co-payment. So of course, many, many people cannot afford to pay even the co-payment. So they don't take the medicine. So this is always one of the problems in the pharmaceutical industry, the medical industry. You can have fantastic medicines, but they're only available for very few people, the people who have the money. And just recently, I've started thinking about a product we have which could be suitable for multiple sclerosis. Do you know multiple sclerosis? No. No. Okay. So multiple sclerosis is an inflammation of the nervous system, and thousands of people have this. And your nerves in your body begin to degrade, and that means ultimately you lose your coordination, and it's a lifelong illness. And eventually, the person is in a wheelchair. And we've started to work on something which we think could be relevant for that disease, multiple sclerosis. So we have to develop the data, and then we have to get companies to get interested in this, and then we secure a licensing deal. Another product we had recently, but we have another spray, a nasal spray. You put this in your nose. If you use this, you will not get COVID or influenza infection. So we're now trying to develop this. We actually have a product which is on the market in Vietnam. And we've done all of the data, cost millions of pounds. We've been doing this during the pandemic. We developed a spray which has utility, has use.
I just had a question about that spray actually.
Yes.
Is it like a prophylactic spray, or
Yeah,
like
prophylactic.
you said that
So during the pandemic, my daughter, who's probably similar age to you, said, oh, why don't we do something for COVID? And at that time, people were developing vaccines. And I don't know if you know about COVID, but there's a major problem with the COVID vaccines.
Yeah.
And the problem is that if you take the vaccine, you will not get, you will not die. Okay, so fantastic, brilliant. But it doesn't stop the virus from disseminating. The virus still enters your body, it can proliferate, and as it proliferates, it mutates, and you get new variants. And that is why today we still have COVID. So, okay, you don't die, which is fantastic. But the vaccine is by injection. So when you have an injectable vaccine, it prevents the worst symptoms. What you need is a vaccine which can be delivered through the nose or orally, because that's where you're infected. When you're infected by COVID, it's something you breathe into your lungs, your nasopharynx. And developing a nasal vaccine is extremely difficult. So what we did, we showed that if you take a type of bacterial spore and you inactivate that spore, if you blow it inhale it into your nose, you stimulate, you can increase your body's ability to fight infection. That's called innate immunity. And in the case of COVID or influenza, it's enough. So what it means is you can take that spray, and if you sprayed it into your nose every day, you'd be very unlikely to get COVID infection or influenza. And if you remember the pandemic, one of the problems was that the first people to get the vaccine were all in industrialized countries. Many, many people in developing countries never got a vaccine because they're at the bottom of the list. So our product is universal. It's something which can be stored without a refrigerator. And it's cheap. I mean, relatively cheap. You spray it into your nose every day. But this then brings up another problem. Unfortunately, with human beings, they don't remember to do this. So, for example, at my age, I can go to the pharmacy and get an influenza vaccine, but I don't do it because I'm lazy. So sometimes, things are more complicated when you begin to think about things. And you might imagine if you lived in a remote village in India, how are you going to get a vaccine? It's not so simple. People have to work, they have other priorities. So the problem with any prophylactic measure is the way people think is, unless there's an immediate danger, I'm not going to worry about it. So I don't take my influenza vaccine. All I have to do is go into the town and I can get it free of charge. But I'm always so busy. When we had the pandemic, we were forced to take the vaccine. We had to do it. So what I'm trying to show is that it's very nuanced, the way, sometimes things are very simple on a piece of paper, but it's more difficult. And interestingly, in the world of probiotics, people do remember because, people, they remember to take their capsule every day because they think it benefits their health. But if someone said to you, I want you to take a spray every day because it would then reduce or abolish the probability of you getting COVID, there's a good chance many people, they just forget or they get lazy. So, but the answer to your question is, yes, it's prophylactic. But some people do take it every day. I don't, but...
All right. Thank you. Yeah.
So I had one question, like more technical. So you mentioned a lot about Bacillus, but traditionally, like everyone uses like lactobacillus, but y'all are using like more of like Bacillus subtilis, I guess. So what made you research into Bacillus as a probiotic?
Well, okay, so there are different ways to answer this question. So when my PhD, I worked on Bacillus. My postdoctoral science work in Harvard was on Bacillus. And I was asking the question of how the spore is created at a genetic level. So I became very skilled in Bacillus and genetics. So that's all I know, okay? it's rather like if you went along with your car and asked for your car to be repaired by the person who repairs the heating, he wouldn't be able to do it. They're different skills. So I worked with Bacillus, and I'm very obviously expert with Bacillus. And I found out that a company in Italy was a company called Sanofi, a very big company, was manufacturing. In fact, I have it here actually. My screen is frozen, so I will unfreeze it. Yeah. So I have a little capsule here, an ampule. You can buy this in India. It's manufactured by Sanofi, a big company. And in this are bacterial spores, and you eat it. And this is 30 years ago, and I remember this, and I was very curious why people are eating this. And that introduced me to the world of probiotics. So the history of probiotics was about 120 years ago. In Europe, the Caucasus, Bulgaria, Armenia, they knew that people living in the mountains were living for an extraordinarily long time. Their average lifespan was something like 85 years. And at that time in England, the average lifespan was about 50 years. So clearly, if you lived in the mountains of this region of Europe, there must be some benefits. And what they found was a Russian scientist, his name was Mechnikov. He went to Bulgaria and Georgia, and he realized that people with long lifespans were eating a fermented milk product, which contained lactobacillus. So he said, aha, it must be the lactobacillus. Well, I could tell you, in fact, it's not true, okay? The reality is that people who lived in the mountain villages, they would spend their entire life living on the top of the mountain. They never leave the town. They don't have cars. And their diet was very simple. You will have the same in India. You will find remote towns where people never leave the town. They spend their entire life in the village or town. And their diet is very simple. Now, if you think about an Indian sadhu monk, they also have very long lifespans. And if you were to ask the person, if you were to ask the Indian sadhu what he eats, you will probably find he has a very simple diet for his entire life. And prolonging your life is probably due to having a very simple diet. But coming back to the lactobacillus, so Mechnikov, he focused on this fermented milk drink and the lactobacillus. And then 20 years later, a Japanese scientist called Chitrita, he then started growing the lactobacillus and he made a milk drink commercially. That product today is called Yakult. And that was the beginning of the probiotics industry. And of course, many, many people started eating fermented milk drinks or yogurts. And I then came along 30 years ago and realized, well, some people are eating Bacillus. Maybe it's more complicated. And what we've been able to show is that every day, I will breathe in about 100,000 Bacillus spores, which are present in the air. And we know this because we know how much air a person can breathe in a day. And we know how many bacteria there are in the air. And most bacteria in the air are spore-forming bacteria, not lactobacillus, they're Bacillus. We also know that if you live in Mumbai, which I think you live in Mumbai, you will only be breathing in 10,000 spores a day. If I live in London, I breathe in 10,000 spores a day. If I live in the countryside, I breathe in 100,000 spores a day. And the reason is because in cities, dense urban environments, most bacteria have been killed. It's a very sterile environment. It may be very dirty, but it's also very sterile. And this is something we call the hygiene hypothesis. Have you heard of asthma, allergy?
Yeah.
Yeah.
So that is an illness which is increased in urban environments. And if you live in the West, my daughter has it. We now know that if you live in an urban environment, you have a much, much higher risk of allergy and asthma. And we've been able to link this to our decreased exposure to plants pollen, so plants, the environment, but also bacterial spores. So people who live in urban environments, you're breathing in a very sterile air. Most bacteria have been killed, and most Bacillus spores have been killed. And we now are putting forward the notion that you need to be breathing in Bacillus spores in the air. You can think of them kind of like a probiotic. So farmers never get allergies, never. Only people who live in cities. My daughter has a very clean environment. The air is clean. The food is very sterile. She only eats in a restaurant. But she has many, many illnesses. Another illness is inflammatory bowel disease. It only occurs in urban environments. Clostridium difficile infection only occurs in urban environments. So in our world today, we have large numbers of people living in urban environments. We have all these new diseases which have emerged. Eczema is another one. So we believe that the bacterial spores which we acquire from the air we breathe is being depleted in urban environments. So part of what we're trying to say now is that, by eating bacterial spores, that's the case for their use as a probiotic. But coming back to lactobacillus, there is a large industry which has made a lot of money from fermented milk drinks and yogurts. And there's nothing wrong with eating those products. I make that clear. Okay. And that's why historically everyone talks about lactobacillus.
I just had one thing. So as you were saying about like the urban areas and allergy, so I have eczema currently and like allergic rhinitis. So is that also like related to
Yes.
lack of exposure?
Yes. So if you have allergic rhinitis,
Mhm.
we have also conducted a study that shows that if you take this spray,
Mhm.
you should see your rhinitis disappears.
Okay.
I promise you that.
Okay.
I promise you this, okay?
Yeah.
We've done a study in Vietnam on allergic rhinitis.
Mhm.
And we've shown that if you've taken that spray, well, you reduce the symptoms by at least 50%. So instead of having it for 10 days, it goes to 5 days. My daughter has allergy. She takes this spray and her allergy disappears.
Okay.
And yes, it's complicated reasons, but you're basically restoring bacteria because you live in an urban environment. It's probably why you are getting the rhinitis.
Yeah, I had a question regarding so you talked about bacterial spores and how you work with them. So I just wanted to know more about how you use them in your probiotics and products in general.
Well, so the formulations, we have to fully characterize these strains. We have to show they're safe. And then we need someone to produce them. So you probably know originally we did a lot of production in India with the company Synergia. And we work with some Vietnamese companies who also manufacture. And then the bacteria are produced in liquids, and then you remove the liquid and then they're dried. And then you put into a capsule and you eat them. In the case of the spray, we have to put it in a liquid, which you spray in your nose. So there's a lot of techie stuff, which I have to tell you, I'm not so familiar with this because normally that's outsourced. Other people do that.
Okay, so just one last question that I wanted to ask was, Like, what is the future of probiotics other than gut health?
Other than gut health, well, there are other areas people working on. Obviously, the nose, the nasal application. You have to be very careful when you spray something in your nose. You remember this. But another big area is skin health. You hear about this. I think that, what do they call it? There's a name for it. I can't remember. The skin microbiome. But people who have acne, there are a number of skin complaints. Body odor is another one.
Mhm.
Many years ago, I worked with a company called Unilever, and they wanted to make a deodorant which contained bacteria which kill the bacteria which produce body odor. Also, with the bacteria we're also working on a methane project. We're trying to use the bacteria to reduce methane emissions. This is not probiotics, but it's an application for Bacillus. So as we speak now, we are doing a study in Vietnam with rice, and we're adding Bacillus to rice when they grow rice, because rice is one of the major emitters of methane in the world. So actually a major problem in India also, because the rice is kept in wet water, which produces methane. And we're working with a company in India now, it's in Vietnam now, excuse me, where we produce bacteria and we mix it with a fertilizer, which they then give to the farmers to see, can we reduce methane emissions?
Mhm.
Do you know what one of the big problems with that would be? You know about, obviously, climate change and carbon emissions. So if I say to you, we have a bacterium which you can add to rice fields and it reduces methane emissions, you would think that would be great, wouldn't you?
Yeah.
Yeah, but actually no one interested in it. You might be, young people are interested,
Mhm.
but if you're a farmer, why would you care? We have the problem in England, everywhere we have this problem. For the farmer, he's not interested. We care. And so the reason is you have to get the governments to be interested. So you have to get governments to give tax incentives to farmers. Otherwise, why would the farmer pay money for something? He doesn't care if methane is produced. So I'm just using that to illustrate that simple ideas which sound great, once you try to take them forward, becomes more difficult. So you have to find a
This is
solution.
very valuable. Like, we learned a lot. Do you have anything to add, Professor?
But science is I'll just tell you some general things. It's can be very boring. Can be very hard work. But it's very satisfying when you can create something which actually has some value. And I'm not talking about money. Usually money is the way in which ultimately everything costs money. But the big areas now are obviously cancer research and gene therapy. So those are obviously very growing industries at the moment. Infectious disease gets less interest. Of course, for a young person, you would think it's obvious. Think about tuberculosis. But when you think about, I'll just tell you some general things. When you think about the world's health problems, tuberculosis, major problem in India, right?
Yeah.
Yeah.
How would you solve the problem? Well, I don't expect you to have the answer, but actually, in the case of tuberculosis, the people have spent maybe billions and billions and billions of dollars trying to develop a vaccine, and it's just not being successful. We used to have tuberculosis in the United Kingdom, and the way they solved it was by improving hygiene and sanitation. So, of course, if you had everyone in India living in nice houses with well separated, etc., the solutions often are there, but very difficult to implement. HIV, for example, AIDS, that can be solved very simply if you just change the people's behavior, the way people behave. But then some diseases, such as pandemics, you need an immediate solution. But science is very interesting. And if you go into academia, then you have the advantage you can actually teach people, which is very satisfying. And you can also conduct your own research. And you don't have a boss, which is the best part.
So I think we can then conclude for the day. So thank you, Dr. Cutting, for taking the time out for us, especially on a Sunday morning. And
No
thank you
problem.
for giving us valuable insights into the area of spores and probiotics.
Absolute pleasure. And hopefully I might see you in India.
Yeah, definitely.
Yeah.
Thank you.
All right.
Thank you.
Any questions, just email me.
Okay, sure.
Yes, of
You.
course. Yeah.
All right. Take care. Bye-bye.